So greetings for the day to all. So I'm here in front of you with the next lecture of artificial intelligence. So today in this lecture, I will cover some two topics mainly and introduce the third topic. The first topic that I'm going to cover the today's lecture is problems and their characteristics. So this is the first topic that is going to be covered in this lecture. First topic is problems and their characteristics. So here we will see what is basically a problem is. What are the different categories of the problem? What is the definition of the problem? And what are different types of problems that we come into in day-to-day life. Then we will also look on to the different characteristics of the problem. Characteristics of a problem is very much important because from the characteristics we come to know many more points about the problem, and it helps in making the decision that how this problem should be handled. So this is very important. That is, first of all, we have to know what is problem, what is the definition of the problem, in which categories the problem lies, and from the characteristics of the problem, we come to know what actually the problem is, how we can solve, how we can handle this problem in our day-to-day life. So it is very much important to know about the characteristics of the problem. Then I will cover the another topic, that is state space search. It is also very important topic, that is state space search. So it is very important. In this, first we will see what is basically the term state means. What is the state in any problem? What is the state? Then we will see what do you mean by state space? What do you mean by state space? And after that, we will do the whole thing, that is what is state space search. What is state space search? So these are the two major topics that will be covered in the today's lecture. I will also touch the third thing, that is search strategy. What are the different search strategies? So just the introduction to this topic will be there, that is search strategies. So to cover these topics, the presentation have been made. You will go through my presentation. First, the presentation will be on the problems and characteristics, then state space search. Then I will just give the introduction to the search strategy. So if anybody going to this presentation, after this presentation, they will come to know about these topics. I again repeat, the topics are problems and characteristics, means characteristics of the problem, then state space search. I'm telling now only during the presentation, you just go through, you will go through and you have to listen properly the definition of the state, the definition of the state space, and the definition of the state space search. What do you mean by state space search? Now I will go through the presentation, and I will just going to share the screen now. So objective, after going through the this definition of the problem, first topic. So please keep it on the upper side or lower side. So after going through first part of the presentation, you will come to know about what is problem and what are the characteristics of the problem. So just start. So what is problem? Anything that is unsolved or that needs a solution. So any statement, any situation which needs your attention and which at present is unsolved, and we need a solution for that. That thing is problem. If there is something but it does not need solution, we do not bother about that. Whatever we do not know about that thing and we do not bother about that, then it is not problem for us, because we do not have, it may be any situation. But if in that particular situation it is unsolved, you do not know about that, and you want to know, you want a solution, then only it becomes the problem. It can be any situation, day to day, whose output, what will be the output. You are curious to know what is the output, but at present you do not have any output, but you want the output to be there. You want the solution to be there, or simply you can say, what is the problem? I will just tell you. So any situation is there. So it is at any state, initial, current state or initial state, and you want to reach to one particular solution, that is the goal state. So reaching from this initial state or current state to the goal state, this is, you can say, a type of problem. So how to reach from this state to this state? This is the finding the solution of a problem. That is the finding of solution of the problem. Next. So to choose an appropriate method for a particular problem. So a problem can be solved by many ways. There are a problem which can be solved through many ways. Many methods can be applied to solve a particular problem. So which method is the best method for that particular problem, or what is the situation in hand? According to that situation, what is the best method to find the solution? So to find the best method, we have to go through the characteristics of the problem. So a problem can have many characteristics. Those characteristics are discussed. The list of characteristics is in front of you. So just I will go through the list of characteristics. Then I will discuss each characteristics one by one. So first is the problem decomposable? Means whatever the problem is in your hand, is it a decomposable one? It can be further broken down into the smaller problems. Second is, can solution steps be ignored or undone? Whatever the steps you carry out, you take finding the solution. So those steps can be ignored or undone. Next is the universe predictable? Means what is the problem? What is the nature of the problem? What is the environment around the problem? Is it predictable or not? Is a good solution absolute or a relative? Means whatever the solution you are finding, it is the just absolute solution or it is just relative. Relative solution means in comparison to. In comparison to, we can say. I will come on to each characteristic one by one. Is the solution a state or a path? Means whatever the solution you have found, is it just a state which leads, which is the final state or the goal state, or this state is just a path which leads to the goal state? Then what is the role of knowledge? How much knowledge is required for finding the solution? And does the task require human interaction. We have to see. So I will go through these characteristics one by one. Is the problem decomposable? Means can the problem be broken down into the smaller problems to be solved independently? Decomposable problem can be solved easily. Means suppose you have a problem in hand. So it is a bigger problem. So can you divide the problem into the smaller modules or the smaller problem? Can you divide it into 3 modules, 3 or 4 or n modules? So P1, P2 up till Pn. Can you divide a problem into the smaller problems? So why we need to divide the problem into the smaller problems? It is a type of modular programming where a big problem is divided into the smaller problems. So because when we deal with the smaller chunk of a problem, it is very easy to solve it. And then the solution of this and this modules can be combined together to get the solution of the main problem. Just see any equation 2 into 3 plus 7 divided by 9 plus 3 into 5. Suppose this is there and now you have get bracket here. So you can, this equation can be solved according to the BODMAS. So BODMAS is the technique which allows you to divide your main problem into the smaller problems. So here, first of all, the bracket will be solved. So then multiplication will be solved. Here also the output will be multiplication will be solved. Then division will be solved. Then plus will be solved. So this is the dividing the main problem into the smaller problems, into the smaller chunks, so that you can get the result very easily and divide. First of all, divide each problem into the smaller problem, solve that problem, smaller problem, and accumulate the result. So this is the way. So if we see that the problem in hand, if it is the decomposable problem, then we should be satisfied that this problem can be solved easily. If it is not decomposable, then it requires very much effort from your side to solve this problem. Clear? Next, can solution step be ignored or undone? Means there is a problem. There is a problem and there is the final solution. Means output is there. No, just we are any state, that is the problem is there and this is the solution. So in between the problem and the solution, many steps are there. Step 1, step 2, up till step n, and we reach the solution. Now the question is, whatever the steps, whatever the operators, what are the operations you apply from reaching from the initial state of the problem to the final solution state. So can these steps can be undone? Can you revert back if you have taken one step and you find that this step is not right? It will not lead you to the final result. So what you can do, you can very simply revert back. But it is not true for all the problems. Sometimes you take a step, but it cannot be taken back or reverted back. It is known as move. It is known as move. So in these cases, so we have to see, it is the very important characteristics of the problem that the can solution steps be ignored or undone. Can solution steps can be ignored or undone. So we have many types of, you can say, problems where we can see, suppose 8 puzzle problem is there. So here you take one move, but if you feel that it is not right, you can revert back. You can revert back in this type of problem. So it is a recoverable. The step or the move can be reverted back. The step or the move can be backtracked, but it is not there. Second is, you take the example of chess. In chess, whatever the move you take, whatever the step you take, you cannot revert back. You cannot backtrack. So that is the type of problem which is irrecoverable, irrecoverable problem. And in some like theorem proving, we say that whether whatever the steps you are taken, they are ignorable or not ignorable. So from this, the solution case steps can be ignored or undone, or it means the problem is recoverable or irrecoverable. So this is very important characteristics. If the problem is irrecoverable, you cannot backtrack, then it needs very utmost attention, utmost care whenever you take any step in carrying out the solution to the problem. But if it is recoverable, then it is little bit easy. So this thing, this property, this characteristics of a problem is very much important. Next. Can solution step be ignored again? So ignorable problems can be solved using a simple control structure that never backtracks. Recoverable problems can be solved using the backtracking technique, and irrecoverable problems can be solved by recoverable style modules via planning. So very much planning is required. So you cannot find the solution, or it is not suggested that in case of irrecoverable problem you should start solving your problem without planning. So it needs a utmost planning, very careful planning. Is the universe predictable? Means you know what can be the outcome, or whether the outcome will be there or not. Are you can say satisfied that you will come to know about that, yes, there you will find the output or outcome. Or if you are not certain that outcome will come or outcome will not come, there is an uncertainty, then we say the universe is predictable or not. If you are certain about the outcome, that yes, by going through this method I will definitely get some outcome, whether outcome is right or wrong, but you will get some outcome, then we say that the universe is predictable. If you are uncertain about the outcome, what will be the outcome? You are uncertain whether it will be. So there, the universe is not predictable, because you know about the environment of the problem, but in the second case, you do not know about the environment about the problem. So just see the example of 8 puzzles. Every time you make a move, you know exactly what will be happen. So there is a certain outcome. On the other hand, when we play bridge, so we cannot know exactly where all the cards are, or what the other player will do on its move. Similarly, in the case of chess, so there the outcome of the next move, that you will win or lose in that particular move, it is not certain. So this is very important characteristic. This is very important feature of any problem. And if we have got the knowledge about this feature about a particular problem, it is very easily to solve the problem. So just so next is a good solution absolute or relative? Means there is a problem. This is the solution. So now we will find out this solution is absolute, means exact. This is only the solution. This is the solution, or it is a relative solution, or it is a relative solution. Suppose I say marks have been, there was a problem to give a particular exam, a result is out. So here a student got 95% marks. So this is the absolute result, absolute result. But if I say X have scored more than Y, X have scored more than Y. So now this is a relative solution. So here in first case, what I am getting, suppose I say X have got 95% marks. So this is the absolute solution. In the second case, I say X have scored more marks than Y. So it is a relative. Or X have scored 10% more than Y. So it is a relative solution when we compare. So any path problems can be solved using the heuristics that suggest good paths to explore. For best path problem, much more exhaustive search will be performed. So this is the definition that the book is giving or the any author is giving. But just see, this is a simple case of understanding this characteristics, whether a good solution is a relative or a absolute. So in this case, it was the absolute, and in this case, it is the relative. Next. Is the solution a state or a path? So I will just tell you also this. So you have got the solution. Again, same, I will make a problem. This is the solution you have read. Now, this solution is actually the final state, means the goal state. Is this solution a final state or a goal state, or or it is the path to the goal state? Means it is not the final goal state, but whatever the solution you have found, you have not found the final goal state, but you have found the solution in such a way that it will lead you to the goal state, that it will lead you go to the goal state. I will just give the example here also. Suppose I start from my home and I am searching any person whose name is, you can say, ABC. Clear? So I went through certain area, moving the different streets. I found one person. I asked, "Are you ABC?" He said, "Yes, I am ABC." So this is the state. So this solution, you have started from the problem from your home. You have taken certain steps and moved to one state or the solution. You ask the person, "Are you ABC?" He said, "Yes, I am ABC." So I can ask any question to this ABC. But similarly, I went to his home, but I asked, "Are you ABC?" He said, "No, I am father of ABC." And ABC is no more, or ABC is left this country, whatever he can say. But so it is a path to the solution. So you can get the address of ABC from its father. If he is not at that place, then you can ask, where is ABC now, from his father. So this is the example, whether the solution, whatever you read, it is actually the goal state or it is a path to the solution. So in this case, it is a path for a solution. So water jet problem, backside. So water jet problem is type of problem, the path, we get the path that leads to the goal that will be reported. So we will do the water jet problem today itself. Next. playing chess. So what is the role of knowledge? How much knowledge is required to solve a particular problem? What so what is the role of knowledge to handle a problem? So certain problems need not do not need much knowledge about that particular problem because it is easy. But some problems need a in-depth knowledge so that it can be solved. Suppose you are talking about any problem or any, you can say, venture for the space. So it needs in-depth knowledge, very in-depth knowledge, so as to solve that particular problem or that particular project which leads to any, you can say, exploration or any inventions which leads cover in the space area. So it needs in-depth knowledge, but sometimes the knowledge is not much required. For just the example, playing chess, knowledge is very important only to understand the search for a solution. But reading newspaper, knowledge is required even to be able to recognize a solution. And third example that I have given, if you are talking about the space problems, you need a much knowledge. Does the task require human interaction or not? So is there, you can say, interfacing is required, interaction is required, because the communication is sometimes a single way, but sometimes the communication is two way. So if there is a two-way communication, then the interface between the two-way communication is required, the interaction is required. So the solitary problem in which there is no intermediate communication and no demand or explanation of the reasoning process. So the problems we do not require any human interaction, those lie under the category of the solitary means alone. So solitarily problem. But the second types of problem where the human interaction is required are known as the conversational problem, in which the intermediate communication is to be provide either additional assistance to the computer or additional information to the user. So this is the topic about the problem and its characteristics. So this is what we have done about the characteristics of the problem and the definition of the problem and with the proper example. So here I'll stop. So now I'll come to the next part of today's presentation and lecture, that is the state space search. So the topic is, just I will write on a board, state space search. Yes, sir. So after going through this part of the presentation, you will get the knowledge about what is state space, what is state space search, and what is the state space search problems. Next, next slide, please. So what happens basically searching for a goal state? So any problem we have done. So what is problem solving basically? Problem solving is searching for a goal state. Just see here. This is the problem and we are taking certain steps. Step 1, step 2, step 3, and we find goal state. We find the goal state. So here what happens? These are the steps that we have taken. So what do you mean by problem solving? So this is the process of the problem solving. You got the problem in hand. You take appropriate actions, appropriate steps that will lead to the solution of the problem. So if you reach to the goal state, then we say that we have find the solution to the problem and problem is solved. So this is the general thing about the problem. So before that, this you have already done. Now you have done the characteristics of the problem. Now what is state space? So before state space, I will just tell you what is the state. What is the state? So here we are with the problem statement. You are given with the problem statement. So that is the initial state. Initial state of a problem. You take one step. You take one step to solve. That is step one. You come to this state. So this state is the intermediate state. S2 you can say. This is the initial state S1. Then you step 1 to take the problem. So I say state is ST1. Now you come to ST2, the second state. Similarly, more steps will be taken and the problem will come to the more intermediate states like STN. That is the intermediate state or STN minus 1. Then finally, you take the step and you reach to the solution. You reach to the solution. Now this solution state, it is STN, or you can say it is a goal state. It is a goal state. So what happens from initial state, you move to the goal state, and in between, whatever the steps you are taking, you are coming to the new state after taking the steps. Mostly your steps should be such that it should change the state and it should carry on. The change should be in such a manner that it leads to the solution state, it leads to the goal state. If the state that is being changed, it is moving away from the goal state, then your steps, whatever the action you are taking, these actions are not right. So you have to change the direction, you have to change the course of study, you can say. So now what is this ST1, ST2, STN minus 1, STNN? So these all, if you combine all these states, when you make a pool of all these states like ST1, ST2, STN minus 1, STN. So this pool of all the states is known as state space. It is known as state space. So similarly, so what is state space? State space is a set of all legal positions, all legal moves. After taking the move, one more position, you enter a new position or new state. That the set of all the legal positions, all the legal moves, those are known as the state space. So starting at the initial state, using the set of rules to move from one state to the another, to take the steps according to the rules and attempting to end up in a goal state. I will also tell you one more example here only. Just see, we have done the addresses. So if it is a 2-bit address, bit 1, address bit 1 and address bit 2. So what is the address space? If the 2 bits are used for the address, what will the address space? So it can be 00, 01, 10, 11. Means 0 address, 1, 2 and 3. So this all is the address space. So this we have already done many times. What is the address space? What is the memory space? Similarly, if there are 3 bits being used, then it will be the 0, 1, 2, 3, 4, 5, 6, 7. Means 8 addresses in the address. Similarly, is the state space. Means how many different moves give rise to the different state, and the combination and the pool of all the moves which result in the different state, that is known as state space. Now, what is state space search? what is state space search? So if you talk about any problem like it be chess, so chess you have many moves from both the opponents. So move 1, it will result in state 1. Initial state is 1, then move will lead to state 1, another move state 2, another move state 3, state 4, state 5, state 6, state 7, and many number of state you can say SN. Now out of these states, some states are your goal state. Some moves leads to you into the goal state of the chess that you can win the chess game. So those states we are looking for state space search. What we are searching from the state space? We are searching the goal state. The search of state space search means searching the goal state or the state which will lead you to the solution to the goal, that is known as state space search. So we apply the different search strategies which lead you to the goal state from the initial or the current state. So this is what the concept of state space search. So many moves are there, many steps are taken. Each step lead to the new state. But you can see some games or some problems, they have definitely only the one state which can be treated as the go state. But some games are or problems are such that there are more than one go state. Means there are different types of not only the single move, there are many moves that can take you to the go state. But in you suppose the cricket game, if anyone has scored 255, then you have to reach 256. So this is the only one you can say move. The move that will lead to pass on the score of previous. That is the go set. But in chess, there are many moves where you can give the checkmate to the another opponent player. It is not only a single move that will lead to the or so that chess you have many moves that will help you to move to the go state. But in the cricket match, if anybody has scored 255, then you have to score 256. So this is the only one move. So this is what we have to see. So what is state space search? So define a state space that contains all the possible configurations of relevant objects. Possible configuration means possible moves. We have to specify the initial state. Now from where we have to start, that is also known as the current state, the start position. Then we have to specify the goal state, state or states. So there can be one state that can be treated as goal state, or there can be more than one state that can be treated as goal state. You have to specify. Then you have to specify set of rules. So what are the set of rules? Uh, because we have to take the move, so we have to follow some rules. In chess also, there are rules for different types of things. Pawns have different rules. So queen have different rules. So that is the thing. Pilot has different rules. So same is there also. So what are unstated assumptions? How general should be rules be? How much knowledge for solution should be in the rules? So this has to be defined. Then only we specify the set of rules and what moves can be taken. That is known as the legal moves. If we take a move and if it is allowed, means if it is satisfying the rules, then that move is known as legal moves. So set of all the legal moves, set of all the legal operations is known as state space. Unlegal operations are not included in a state space. Next. So state space search like playing a chess. So each position can be described by an 8 by 8 array, that is the board chessboard. 8 into 8, 64 locations are there. Initial position is the game opening position where 8 from one side, black side, and 8 are aligned in a horizontal manner from the black and white. Goal position is any position. It is not a single goal position. there is not a single state which is the goal state. The goal position is any position in which the opponent does not have a legal move and his or her king is under attack. That is the checkmate. So legal moves can be described by the set of rules. So what are the rules? So we have two, you can say, sides of the rules. If any rule, there is rule 1, then it is has left hand side and it has got a right hand side. So left hand side are the conditions. So if the condition satisfied, then we take the action and this will become the output. After taking, what will the new condition? So rule has left hand side and the right hand side. So left sides are matched against the current state. So we have any state S1. So if this state follows these conditions, then this step can be taken and we move to the new state. If this state does not follow the conditions which are defined in this particular rule, then you cannot take this step. So left hand side are matched against the current state, right side describe the new resulting state. So any rule has left hand side and the right hand side. And left hand side, there are the conditions. And state has, we are at this state, so the conditions are met. If the conditions are met, only this step, only then this step can be carried out. If these conditions do not match, then some other rule will be applied and some other step can be taken. So water jug problem. So what is the water jug problem? Just see here. Very important problem. So you have given the two jugs of water of any known capacity. Capacity of the water is known. Suppose in this example, one jug is jug A with 4 liter capacity and another one is jug B with 3 liter capacity. But there is no marking, no like this marking is not there. It is not available. Here also given with the availability of tap or any pump from where you can pour in the water. In these jugs. So whatever may be the initial condition, both the jugs are full or both the jugs are empty. That is another case. So the problem is you want the final that any of the jug with the required amount of water. Suppose in this case you want any jug with exactly 2 liters of water. So how can you get exactly 2 liters of water into the 4 liter jug? So this is the final. So initial condition is not known. Final condition is you want 2 liters of water in jug 1 and there can be any X amount of water in jug 2. So this type of problem is known as water jug problem. So initial can be both the jugs are with 0, 0. Then you pour some water in jug A or some water in B and taking into and there is no marking. The final thing is you want 2 liter water. So this is the goal state. You want 2 liter water in a jug having capacity 4 liter. And it is not said how much water you want in 3 liter or jug B. So output is 2x. You want 2x. So in this x it can be 0, 1, 2, 3 and 3. Clear? So what is the different go states you can have? A different go state here is 2, 0, 2, 1, 2, 2 or 2, 3 because this has capacity, maximum capacity is 3. But the go state is your first jug should have exactly the 2 liter of water. So here there are not only a single go state, there can be many go states and one of this state you have to reach upon. So these are the states X and Y. X is the state of jug 1, Y is the jug 2 So what are the different states? This can have, it can be empty, that is 0, 1 liter, 2 liter, 3 liter or 5. It can have 5 different states, and it can have 4 different states. One is empty, that is 0 liter, then 1 liter, 2 liter and 3 liter. So there can be different permutations and combinations of both the states, and start state is 0 0 and the goal state is 2n. I have taken x, we have taken n. So any. So n value can be 0, 1, 2 or 3. But what is the first value? It should be the 2 liter. So attempting to end up in a goal state. So this is the water jug problem. But the chess problem, it was the combinatorial problem. There are many steps, many moves, not a symbol. So it has, therefore it has the combinatorial problem. Combinatorial problem is there are many states, millions of states, that because each and every, you can say, can have a different person can have a different moves, and each move can give rise to further opponent move, and it has many states. So therefore chess problem is known as combinatorial problem. But here the number of states are not many more. It can only, it can have the different, you can say, the permutation and combination, because 5 states can, this state can have, 4 it can have. So you can have the different combinations, and it is feasible, but it is not the combinatorial. But in chess there are many moves. So just you can see the current state, then you will loop until reaching a goal state, that is 2 0. Now you apply the rule whose left side matches with the current state, then set the new current state to the resulting state 0 0 0 3 3 0 3 3 4 2 0 to 2 0. So you reach to 2 0. So this is one of the goal states. You might reach to 2 1, you might reach to 2 2, you might reach to 2 3. So all will be the goal state. So certain rules are there. So x is y. It can be 4y only if x is less than 4. You can put 4 liter of water here only if initially it is less than 4 liter. And you can put 3 liter here only if y is less than 3. So this is the rule. These are the conditions. The rules are nothing but the conditions are applied. Next. So this is all about this topic, that is state space search. So what is state? What is state space? It is the combination of all the states. And what is state space search? So in state space search, we are finding the goal state from your whole state space. So this is all about this topic. So I will close here about the state space search. So we have done the problem and its characteristics and state space search. Now coming to the last leg of today's presentation, and the last part is the search strategies. Next. So after going through this presentation, you will come to know about the different search strategies. What are the different categories of the search strategies? So again, this thing we have already done. What is problem solving? It is searching for a goal state, and there are many different strategies through which we can look upon to the goal state. And all those strategies, all the different categories of the strategies, that we will cover in this lecture. So search strategies. So first of all, what we are searching state spaces with us, with the legal position. We start from the initial state, then using the set of rules, we move from one state to the another and attempting to end in a goal state. So to do all these things, various strategies can be implemented to reach a goal state. So now the selecting the best strategy is the key point in this regard. So characteristics of the problem helps in making such a decision that which strategy we should apply to reach to the goal state. So it is very important. Next. So what is the good strategy? Many strategies are available. So what is the characteristics of a good search strategy? First is it causes motion. So your strategy should be such that it should cause the motion, means it should, whatever the step you take, it should change the state, and that state should be in the direction of the goal state. So it should make some changes. That is, it should cause a motion. Otherwise, it will never lead to a solution. Or we can say there is a deadlock. If the state does not change, whatever the step you take, or you are unable to take the further step, that is known as the deadlock. So your strategy should avoid those deadlocks. Second is it is a systematic. Your strategy should be systematic. Otherwise, it may use more steps than the necessary. Means proper planning should be there, and then you start. If it is not in a systematic manner, you may reach the solution, but the steps you carry out, it will be the more than the optimal solution. And last is it is efficient. So find a good but not necessarily the best answer. So if it is not efficient, then you can find the good solution, but it not maybe the best solution. But we should always try to find the optimal solution, that is the best solution. So choosing a strategy is very much important, and you should choose those strategies which have these characteristics. So categories of search strategy. So there are two categories. Number one is uninformed search. Second is informed search. So in uninformed search, you do not have any other information except what is the initial state and what is the go state, and what are the nodes. Suppose we are finding some go state in a particular tree. We are searching for a go state. So you have only the information about what the nodes are. Nothing, no other information about the nodes. What is the distance from this node to this node? How much time it will take, or any other information about this. On the other hand, informed search techniques. So here, along with the initial state and the final state, you also have some information about those states, or how to reach from one state to another. Some information is there, and you apply that information, which is known as through some heuristic function. You apply some heuristic function and you evaluate that which path will be best. Suppose in this tree, you have two options. You can move to this thing or move to this path. So you have some information, and on the basis of that information, you will have some evaluative function. Evaluation function. After implementing the evaluating function, you will come to know which is the good path, this or this, what you will choose. That type of search is known as informed search, or it is also known as heuristic search. Heuristic search, because this evaluation function, it needs some information, it has some heuristic. You apply some heuristic and then find the solution. So this type of strategy is known as the informed strategy. It is also known as open search, and uninformed search is also known as blind search. So different names can be given. So uninformed search is also known as blind search, but the heuristic search or the informed search is also known as open search. So uninformed, also known as blind. Informed search is also known as open search. So it is also known as clues. So it is heuristic or open search. So these are the different names given to the informed and uninformed search. So uninformed search, blind search, having no information about the number of steps from the current state to the goal. No any other information, only we have the information that this is the initial state or this is the goal state. But in informed search, more efficient than uninformed search because you have more information about the nodes. Next. So blind search, two important techniques of the uninformed search or the blind search are breadth first search and the depth first search. You all may be knowing about these searches. So in breadth first search, all we do what? Expand all nodes of one level first. So what is the breadth first search? So if this is the tree, so we have to search any goal state. So first it will traverse first level, then it will traverse the nodes of the second level, then it will come to the third level. But in depth first search, what happens? It will go in depth of one particular branch first. First it will go here, then it will come here, then it will come here, then it will move back, then search here, then it will move back. So these are the two strategies. One is the breadth first search and another is the depth first search. In depth first search, we expand one of the nodes at the deepest level. So you can see the traversing path with the black nodes in the given slide. So this is more information about the breadth first search and the depth first search, that is time, space. There you can say optimality, completeness or not. So one thing is this thing. Next. So one thing is important about uninformed search and the heuristic search. So in heuristic search, what happens? First, go through the heuristic search. So heuristic, it means involving or serving as an aid to learning, discovery or problem solving by experimental and especially trial and error methods. Heuristic technique involves or improves the efficiency of the search processes, possibly by sacrificing claims of completeness or optimality. For this, I will discuss with you completeness or not. So what happens in uninformed? It has got the property of completeness, but informed, it can be complete or incomplete. Both the situations can be there. It is not guaranteed. Completeness is not guaranteed. Completeness means, suppose in you are searching some tree. So if your this is the goal, if goal is present, if goal state is present, definitely you will reach the goal state. You will not miss out. Definitely you will get the goal state. But if the branches is very high level, it may take time. It may take time. May not be very fast. But if goal is present, definitely you will reach to the goal. But in informed site, sorry, informed searches, we look upon at every step. There are many branches, are there many paths are available, and you choose the most promising branch or path. So in that criteria, you may lose the path which actually has the ghost. So therefore, solution is not granted, but that technique is very efficient and very fast. If you reach to the solution, definitely you will reach the solution more early than if you would have applied the uninformed search. So heuristic is for combinatorial explosion. So because there are many, you can say search space is very large and you could not search all the things. Therefore, you choose the most promising path. So optimal solutions are rarely needed. So this is the, you can say, definition characteristics of the heuristic search. The final solution is not guaranteed, but it is very fast. Just example, the traveling salesman problem, that is nearest neighbor heuristic is applied there. In the traveling salesman problem, so what type of heuristic is applied? You
at moment you are at a traveling, say any salesman is at a particular city, starting city. So from here he can reach to any of the city, but it chooses the closest city to the current city. So it moves to the closest city. And the city he has already visited, it crosses that. Then from next, the closest city he reached there. From there, he again searches all the cities which are neighbor to that, and again he search for the closest one. So this heuristic is applied in distance. The city is which is very less distance, he chooses that city from the current city to be first, and he repeats this until all the cities have been visited. So here the heuristic is applied, that is the distance, the closeness among the all the cities, all the neighbor cities from the current city. So this is the simple example of the heuristic search. So we have done with the search strategies, the main categories of the search strategies, that is informed and uninformed search. So today we have covered problem and its characteristics, state space search, and search strategies. So this is all for today's lecture.